So hi friends. So good evening everyone. So let's start the session for today. Is my voice audible? Yeah, thank you. So in today's webinar, we are going to discuss about pruning. Pruning in decision tree. So what is pruning first? Pruning is nothing but we are cutting down the branches of the tree. So you can see a scissor picture here. So it's nothing but we are trimming the branches of the decision tree. That is what pruning means. So first let's try and understand what is decision tree. Then we can come back to pruning. So a decision tree is nothing but a tree-like structure algorithm or a rule-based algorithm. It's nothing but it's similar to a flow diagram. It is a supervised machine learning algorithm. We can use this decision tree for classification as well as prediction problems, but most probably we'll be using it for classification type of problems. Right? So in decision tree, the rules are created. Hence it is a rule-based algorithm. Rules are created. With the help of these rules, we are going to make the decision. And in decision tree, we have 3 nodes. So this is the root node. And this is internal nodes. And this black one is called as leaf node. And these are called as branches. So we have 3 types of nodes here. One is the root node, internal node, and the leaf node. The part which is connecting these nodes are called as branches. Right? From root node to leaf node is called as one rule. The path from the root to the leaf is called as one rule. Similarly, we can count how many rules does the decision tree has generated. Right? So this is what decision tree is about. Yeah. And yeah, the advantages of decision tree. They are very interpretable. Right? And they require very less pre-processing stages. And it can support both numerical type of data as well as categorical data. Categorical data is nothing but non-numeric data. And also we can have multiple outputs. It can able to handle multiple outputs. And it is a white box model. What does a white box model means? It's nothing but all the computations or calculations which is happening in the decision tree, we can know it is explainable. It is called as white box model. What are the disadvantages of decision tree? So decision trees are prone to overfitting. They do not generalize the data. They tend to overfit. Overfitting is nothing but we are training the model. And if my training accuracy is high when compared to test accuracy, then it is overfitting model. So this is one of the major disadvantages of decision tree. And also, if you have the data set, no, imbalanced data set, it may, no, the decision tree may create a biased trees. Due to some classes may dominate due to imbalance in the data. So it is recommended to balance the data set first, and after that you can fit to your decision tree model. So these are the disadvantages. One is overfitting and one is the imbalanced data set. So to overcome this overfitting, we are going for pruning techniques. Right? Yeah, these are the problems. As I said, it has an imbalanced class. So what is the solution for this problem is we need to balance the data set before fitting into the decision tree. And the second problem is overfitting. So how can we solve the problem of overfitting? With the help of pruning techniques. We have two types of pruning. One is pre-pruning and post-pruning. Pre-pruning is nothing but even before your tree is constructed, even before your tree is fully grown, you're going to cut the branches of the tree, or you're going to limit the growth. That is called as pre-pruning. Post-pruning is first you allow the tree to grow, and after that you're going to shape the design. Shape it. That is called as post-pruning. Yeah. Pre-pruning technique is also called as early stop method. We are stopping the tree before it has been grown fully. Right? And in pre-pruning technique, we use the hyperparameter called as grid search CD. The hyperparameter tuning is nothing but there are different types of parameters which is available in the decision tree. We are going to tune it in order to achieve the performance of the model, enhance the performance of the model. So for that, we are going to use grid search CD to find the best parameters. And then we are going to use those parameters to fit to the tree. This is for pre-pruning technique. And what is post-pruning? As I said, we are cutting the branches or limiting the branches of the tree after the creation of the tree. This is also called as backward pruning. Right? It is used when we have a tree having a large depth and when the model is overfitting. As I said, my training accuracy is high when compared to my test accuracy. In such cases, we go for post-pruning technique. It reduces the size of the decision tree, which slightly increase the training error, but drastically decrease your testing error. Right? So we can use this pre-pruning and post-pruning techniques to enhance the performance of the model. And in pre-pruning, we saw the hyperparameter as grid search CD. In post-pruning, we are going to discuss about a technique which is called as complexity measure. The parameter is called as alpha to define the cost complexity measure. This is a formula for calculating that complexity measure. So where this T, alpha of T is the number of terminal nodes in T. Terminal nodes is nothing but leaf nodes. So number of terminal nodes in T. And R of T is nothing but the misclassification of the terminal nodes. It's nothing but the records have been misclassified. The classes have been misclassified. That is R of T. So for this, we are going to use a parameter, as I told you, alpha. It is called as CCP underscore alpha. So which can be used to calculate those values in the decision tree. Right? For pre-pruning, we are going to use grid search CD, and for post-pruning, we are going to use this parameter CCP alpha. complexity measure. Now we can see what are the advantages of pre-pruning versus post-pruning. So pre-pruning is faster when compared to post-pruning. When, no, especially on large data sets. If we have large data sets, we can go for pre-pruning and the operation is faster. And also if we have more number of features or more records, say for 20 features or 30 features, we can go for pre-pruning. And pre-pruning sometimes give even better results than post-pruning, the accuracy. So what are the advantages of post-pruning? This pre-pruning pre-pruning is greedy. It's a greedy algorithm. Decision tree is a greedy algorithm because it makes very greedy choices. It always looks for the values which gives the best. Hence, it is a greedy algorithm. Right? And these are the advantages and disadvantages of pruning. Why we are going to do pruning? We are going to limit the complexity of the trees. Nothing but limiting the branches of the tree. So we can create a simple interpretable trees. And we can reduce the overfitting. Right? And we can fit the data well and gives the best performance. One of the disadvantages of pruning is when compared to other models, ensemble models we are having, such as random forest, bagging, boosting, voting, stacking, all these are other ensemble models we are having. And compared to all those models, this pruned trees accuracy is not that much good. That is a major disadvantages of this pruning technique. Right? Yeah. So decision trees may have advantages over other classification or regression techniques, but one of the major problems we are going to face is overfitting. And this overfitting can be overcome with the help of pruning techniques. So we can also see the hands-on how pruning techniques are handled, what is pre-pruning, how we are doing with the help of research CV, and post-pruning, how we are going to do with the help of CC alpha. Let's see the coding. So clear till now what is decision tree and why we are doing pruning and what are the techniques in pruning? Yeah. So this is the code which we have given for your understanding. So decision trees are often prone to overfitting. To correct this problem, we are going to use pruning
Ma'am, can you
techniques.
speak a little bit louder?
Your voice is not audible to you?
No,
Hello?
ma'am. Not audible, ma'am.
Now it is clear? I have actually full volume. Yeah, now it is clear?
Yeah, it's clear, ma'am.
Yeah, thank you. So first what I'm doing here is I'm importing the basic libraries. What are the libraries I'm importing? Pandas. Import pandas as PD. Why I'm going to use this pandas? This is for data manipulation, for reading the data into data frames. Right? What is data frames? I assume you all know what is data frames is, right? Data with rows and columns. So for that, I am importing pandas and I'm importing matplotlib.pyplot.plt. This is for visualization. And Seaborn is advanced visualization, and Matplotlib is like basic visualization tool. And NumPy as NP for numerical calculations. I'm going to import this NumPy. And from sklearn, sklearn is nothing but a machine learning package. From sklearn, I'm importing the tree for tree visualization. To create the flowchart or tree-like structure, I want to import tree as tr. These are the basic libraries I'm importing first. Then I'm importing my data set. Here I'm using iris.csv. Right? CSV is nothing but comma separated value files, which is similar to Excel files only. So here I'm using my pandas.read_csv file to read the data. And I'm selecting only 3 columns for my easy interpretation. So I'm doing iris.lock. I'm locking 3 columns here. And iris.head. This head function will give you top 5 rows. That is nothing but 0 to 4. You can see here. The columns are sepal length, sepal width, and species. Which species is belong to? Iris setosa. Right? So this is the data set which I am going to work on. Next, what I'm going to do is I am going to drop my species column because I don't want it for numerical calculations. So I'm going to drop my column. Yeah. Now, I'm creating X and Y, and in my X, I'm dropping my column species. This particular column I'm dropping, and sepal length and sepal width, these 2 columns I'm storing in my X. And in my Y, I'm storing the species column. So according to these 2 features, based on the sepal length and sepal width, I'm going to classify my species. Right? This is what I'm going to do. And then I'm going to split my data. So for that, I from sklearn.model selection, I'm importing train test split function. And my test size is 0.20. I'm specifying like that because if my data is, for example, I'm having 100 data, I'm going to split 80% of data on training and 20% of data on testing. That is the test size I have specified here. So then I'm importing my decision tree classifier from sklearn.tree. Right? And I'm fitting my data into it. X-train and Y-train. Tree.fit, X-train and Y-train. And after fitting my model, I'm going to go for the prediction. Right? Train prediction and test data prediction. And I'm finding my tree depth. What is the depth of my tree? So for this, I'm going to use the function tree.get_depth. My depth of the tree is 10. Now I'm going to check for the train accuracy as well as test accuracy. So for that, I'm importing accuracy_score from sklearn.metrics. So I'm printing my train accuracy and test accuracy. So you can see here, my train accuracy is 95% and my test accuracy is 63%. There is a huge difference in it. Since I told you, if the training accuracy is higher when compared to test accuracy, the model is overfitting model. Hence, we go for pruning techniques. So in this, first we look into the pre-pruning technique. In pre-pruning, what I'm going to use? Grid search CV to find the best values in order to train the model. So for that, I'm importing grid search CV from sklearn.model selection. And I'm choosing all my hyperparameters. These are the hyperparameters. Criterion is equal to entropy or Gini. This is nothing but measure of impurity or measure of error. And splitter is nothing but randomly I'm splitting, best random. Maximum depth of my tree, maximum samples I want, maximum split I want. All those things I'm specifying here. Right? And I'm fitting my X train and Y train into my grid search CV. Now I'm printing my best parameters here. And with this best parameters, these parameters, I'm going to go for the decision tree classifier, and with the help of best parameters, I'm defining here. Then I'm going to again fit my model, X train and Y train, and go for predictions, X train and X test. It's nothing but accuracy underscore score. Same process only, but with the help of this hyperparameters. Initially, we don't have this hyperparameters. We directly fit into decision tree classifier. Now, with the help of grid search CV, I found out the best parameters. Then I'm going to fit my model and go for the predictions. Now my accuracy, see, my training accuracy is 77 and my test accuracy is 76, almost the same. Now my model is a good model. Now I'm plotting my decision tree. This is the plt.figure with the help of matplotlib. I'm plotting my tree. This is my decision tree. It will look like this. This is the root node. The top node is always the root node. And these are the internal nodes we are having. And the final nodes, the last nodes are called as leaf nodes or terminal nodes. So this is how a decision tree looks like. Now we'll go for post-pruning technique. In this, I told you we'll be using the parameter CC alpha. That is nothing but measure of complexity. Right? Yeah, I'm creating the tree dot cost underscore complexity. I'm fitting my X train and Y train, and I'm calling my parameter, my path as CC alpha. So these are the values it will give. And I'm checking for my parameter. Length of my parameter is 18. Alpha value is 18 here. And I'm checking for the minimum and maximum values as well. And again, what I'm doing, I am creating an empty list, right, to append the training accuracy as well as the test accuracy. Then I'm creating a for loop. For I in alphas, I'm calling my decision tree classifier, and inside that I am defining a parameter CC alpha is equal to I. I is nothing but the iterations which is having in the alpha parameter. Then again, what I'm doing, tree.fit X train, Y train, training my model and doing the predictions on my train and test. So after doing the predictions, I'm checking my accuracy as usual, train accuracy and test accuracy. And I am appending these two accuracies to my empty list here. So in order to visualize it, I'm using Seaborn. SNS is nothing but Seaborn. And I'm defining the plots, train accuracy. So Y is equal to train accuracy and test accuracy. And these are the labels. Right? And this is the visualization of the accuracies. So you can see here in this graph, this blue line is the train accuracy. And this orange line is called as test accuracy. And on my x-axis, I am plotting my hyperparameter alpha. And on my y-axis, the accuracies. So you can see in this point where the train accuracy and the test accuracy is maximum. And the value is 0.02. So from this graph, we can take the alpha value as 0.02 since we have the maximum accuracy for both test and train here at this point. So I'm going to choose my value as 0.02 for the alpha value, hyperparameter value. And I'm going to use this alpha value to my decision tree model, final model. So I'm calling my model decision tree model. This is my final model. And here I'm going to define my hyperparameter as 0.02. This value we took from the visualization. And again, I am fitting my model x underscore train and y underscore train. Training my model. Then what I'm doing, I'm predicting with the train data and test data. And again, see, the same process only, everything. Only we are doing the changes in the hyperparameters only. So the accuracy for train and test is same. Both are showing 80% of accuracy. So hence it is a good fit model. Now again I'm plotting my tree with the help of matplotlib. So this is my final decision tree. So we get better accuracy when we do the post-pruning techniques. In pre-pruning, the accuracy we got is 76%. In post-pruning, we reached nearly 80% of accuracy by using the alpha as a hyperparameter. Right? And this is the root node and this is the leaf node. And from root node to leaf node, I said this is one rule. Similarly, how many rules are created? 1. This is 2. See, this is one rule. And from here, this is second, third, 4, 5, and 6 rules we have created. We have 6 rules here. So lesser the rules, better is the decision, right? So we always go for less number of rules to make decisions better and faster and quicker also. So this is the advantages of post-pruning techniques. Clear? So clear, guys? What is decision tree? And what is the overfitting model means? How to overcome the overfitting model? What are the technique we applied to for overfitting? That is pruning techniques. And we have 2 types of pruning techniques. One is pre-pruning and post-pruning. And when we did the hands-on, we got the result as post-pruning technique has the better accuracy when compared to pre-pruning technique. So any doubts regarding this?
Ma'am,
Yeah.
I'm training all okay, but we are facing issue for we did not get any mail from your side, ma'am. I mean, after class, attending class, many of you did not get any code or PPT or video, ma'am.
Okay, the recorded videos you're talking about,
Yeah,
right?
record video not issue, but the coding part PPT is most important part, ma'am.
Okay.
From the many students facing this issue, I can escalate them, but it's not respond properly, ma'am.
Okay. I'll check and I'll let you know. Because do I have an option of attaching here? If possible, I can do. No, I don't have an option of attaching. Yeah, I'll convey this. I'll convey a query to our team, and most probably you'll be having the codes on your mail.
Yes, ma'am.
Hello, ma'am.
Yeah, hello. Yeah, tell me.
Yeah, so ma'am, that after grid search CV, we are doing best parameters, right?
Yeah.
So that best parameters we are doing on train data or the whole data?
No, the parameters is nothing but we are fitting for a decision tree classifier. Inside the decision tree, I am choosing the hyperparameters. That is not about the training data or test data I'm speaking about. Right? As usual, we are splitting the data into train and test only. But before that, I am calling my model, right? Decision tree classifier. Initially, I am not specifying any parameters inside. So after that, in pre-pruning, I am specifying like grid search CV. And in post-pruning, I am using the alpha values just because I'm using those hyperparameter value to reduce the number of rules, to enhance the performance of the model only. You can see here, after that, we are training with the training data only, no?
Yeah.
See, after this is nothing but the hyperparameters which I'm passing inside my model. After that, I'm training my model with the train data and testing my model with the test data. And the process is same. Only I'm specifying the parameters inside my model. That's it. That is the difference. But the rest of the process is same only. As usual, you're going to train your fit your model under your train data, right? That means your 80% of your training data you're going to use to train.
Yeah.
And 20% of your data going for test.
Yes.
The same process only. This doesn't,
But like,
yeah.
you think best parameters. So what confusion I had about the best parameter is like, if you see, like if you take only train data base parameter, then sometimes we get 90%, even sometimes in decision tree we get 99% accuracy. That's why it's some.
No, that is nothing related to train data or test data. See, this is what you're asking about, right? This is a decision tree classifier. This is the model, right? Initially, I have not specified any parameters inside this parenthesis. Now what I'm doing is I am doing my hyperparameter tuning here. My criteria is that I'm using the entropy. Entropy, what is entropy? It is the measure of error.
Yeah, ma'am.
Right? And my maximum depth, how much depth, it is nothing but you're designing the tree. I can give you in a simple way.
Yeah, that I got. Like that
These
is
are the
hypermeter.
are the things which we have got from grid search CV. And we are applying those values into my decision tree classifier. Why we are doing this is, this is nothing but maximum depth, minimum sample leaf, and maximum, you can also go for maximum samples and maximum split also. This is nothing but the split. You're designing the tree. That is what you're doing here. This doesn't speak about the training at all here. Training happens after this line only. Here only the training happens. Can you see the highlighted one?
Yeah, right.
We are training the model over the train data only.
Okay. So like
this is nothing but you're designing your tree according to your requirement. That's it.
So like it is just a little bit theoretical question. So can you just explain like on what basis they are giving us best parameters? There should be some basis.
All calculations are happening, internally, right? We cannot visually see that. That grid search CV is that parameter which we are using to find the best values for this decision tree. All these calculations are happening internally only. What you can do is you can just change these values, right? It is 4. Instead of 4, you can give 5 or maximum leads with. You can change these values and you can experiment how your tree looks like. You can do those experiments also.
No, because I did it for one. I was doing one sample, and when I did grid search CV, it gave me like best parameter, like what it has give for the train data, like max depth only is equal to 1. That's why I got that term.
No, it is not like that. This is the research CV parameters. So what is the maximum depth you should give? What is the sample split you should give? So in what basis you're splitting your data? You're splitting your tree based on randomly only. So all these are, to give you a better clarity, you're designing a tree. That's it. Nothing is related to training. After this only you're going for training. Can you see here? You're defining in tree underscore pre, and after that I'm fitting the model my training data. Then as usual I'm going for the test data. This is the process.
Okay. So in grid search CV, we are taking all the points into account, like entropy, Gini, or whatever it is, max depth, max sample, and cumulatively, whichever is giving higher result, that parameters will take.
Yeah. That is hyperparameter tuning.
Okay, got it.
Yes. Okay. So okay guys, can we end the session?
Ma'am, what is the difference between random forest and decision tree, ma'am?
See, decision tree is actually one tree, right?
Yes, ma'am.
Random forest is, what is a forest actually? Generally I'm asking, what is a forest?
Generally, forest means all animals and all those things will be there.
And the forest will be having lot of trees inside it, right?
Yeah.
So multiple decision trees are formed. That is called as random forest.
Okay.
Here we are having only one tree.
Yes.
In
And
random
this
forest, we'll be having multiple trees. That's it.
and in random forest they will cut some pruning. No, ma'am.
No, everything will be there, but little difference is there when compared to decision tree and random forest.
Ma'am, Gini value should be between 0 to 0.5, ma'am.
Which value?
Gini impurity.
See, Gini is nothing but the measure of error, I told you, right? Gini and entropy both are same only. Two different terminologies, but the working is same. It is a measure of error or impurity. Either Gini, by default, it is Gini only.
Okay, ma'am.
If you want to specify that, mathematically, the formulas are different. That's it. But both are going to work for the same.
Okay. If the data is more, so better to use Gini, ma'am.
What?
Gini value, Gini impurity will be good, ma'am. If the data.
No,
Which
that you
data?
need to, that is all experimental only. Based on the data, the values will differ. You need to check, first you go for Gini.
Okay.
You observe the, what is happening. And then you can go for entropy. All these are experimentals. As I told you, you can change the hyperparameters values here. Every values you can change here and see. You can change the criterion. You can change the split. It is not limited to this. Here we have given only 1, 2, 3, 4, 6 hyperparameters. There are many hyperparameters which is also available. You can try with all those things. All are experimental only. Accordingly, your tree will look like. That's it.
Only today one class, ma'am. Tomorrow the same.
No, only one class. Today it's
Thank
over.
you.
Yesterday I couldn't join you because I'm actually I was power shutdown in my place, so I was not having a backup. So extremely sorry for you guys. You were waiting online.
And not a problem, ma'am.
Yeah. Okay. And today's that's all. The webinar is over for today.
Thank you, ma'am.
Thank you.
Where do we get this recorded video, ma'am?
Yeah, I'll check with the team and I'll let you know, guys. Yeah. Because I was not aware that you guys didn't receive this video. I'll talk to the team and I'll.
Bro, they will not upload, bro. short time videos, 30 minutes, 1 hour.
No,
Okay,
all the
bro.
webinar. Yeah.
They will not upload, bro. Webinar.
Yeah. Okay. Thank you, guys.